Okay, I'm back. Now it says to record the mass of the ball. Well, you're not going to have a ball, so you're going to have a can. So you're going to record the mass of the can, and it should be written in grams on the side of your can. And then you need to convert it to kilograms. That's very important. So you're going to take that number and divide it by 1,000. So if the mass of the can is in grams, take that number, divide it by 1,000, put it into that box where it says mass of ball. So substitute the word can every time it says the word ball in the lab. Okay, now you're going to take all of this information from data table 1.61 and you're going to transfer it into data table 1.62, which is down at the bottom of the lab. So keep on scrolling until you get to data table 1.62 and transfer your information into that data table so that you'll have the height that the ball was dropped from in meters. So you need to make sure that all of those vertical heights were in meters. If you measure it in centimeters, all you got to do is divide by 100. If you measured it in inches, you're going to have to go to Google and then type in that distance and say inches, and then next to it put the word meter and then hit enter, and it will automatically convert it for you. Okay, then you're also going to have the average distance that the ball rolled on the ground. So do not include the distance on the ramp. So it's going to be the horizontal distance that the can rolled on the ground. And you're going to enter that data. And then you also had the average amount of time it took for the can to roll on the ground before it came to a stop. Okay, so you've now filled in those three columns. Alright, now we're going to go up to analysis. So what type of energy did the ball have before it was released? So when you had your can up here on the ramp, okay, what kind of energy was that? So go into your notes and find out what was the energy of position. Okay, now you're going to calculate it. So you know what the formula for potential energy is. You know what the mass of the can was. You know the height you released it from, and you know what little g is. So that you're going to get out your calculator and calculate the potential energy of the can. And then record that for each of the 5 heights that you release the can from. Okay, now let's go to question number 2. What type of energy did it turn into at the bottom of the ramp? So the can was up here. The energy was potential. When it got to the bottom of the ramp, that potential energy was converted into, begins with a K. Okay. Now you should know what the formula for that is. Okay, what is the formula for kinetic energy? So, if you set your potential energy, which you have just calculated, you know what the potential energy was. Set that equal to the kinetic energy. Now you know what the mass was. So that means all you got to do is solve for the letter V. Okay, and then once you have solved it for the letter V, you're then going to put that in to the 5th column. It says speed of ball at the bottom. Well, this is going to be speed of can at the bottom of the ramp. Alright, now you're going to go to, okay, now this gets a little bit tricky here. Question number 4, what formula relates the energy of a ball to the distance that it rolls? Okay, it begins with a W. Okay, what's its formula? So what's the formula for work? Force times distance. So that what we could do is we could set the energy that it had, that potential energy, which was turned into kinetic energy, which is going to be the same number. So the kinetic energy that the can has at the bottom of the ramp is the same as the potential energy it had at the top of the ramp. So you could set the kinetic energy that you've already calculated equal to force times distance. Okay, now the next thing says on number 5 is substitute what the force is. So for using Newton's second law, force is equal to ma. So now what have we got? We now know that the potential energy is equal to the mass of the can times the acceleration of the can times how far did it roll. Now I want you to take that equation that I just said to you and solve it for A. So find out what the acceleration of the can would be. And then take those numbers and put them in the data table. So the next column says acceleration of the ball on the floor calculated. And you will have different accelerations. Now, just to make sure that you're doing this right, everything should be increasing. So that starting with the smallest height that you release the ball from, it should roll a certain distance. You should notice, and it took a certain amount of time to do that. What you should have noticed was that if you increase the height that you release the can from, it should have rolled further and it should have taken longer. So you might want to verify that. And also you should have noticed that the higher you release the can from, the more potential energy it's got, and the faster it's traveling when it gets to the bottom of the ramp, and the more acceleration it's got. So you might want, once you've gotten all of these numbers calculated, look at the pattern that it makes. So a small height produces a small distance that it rolls, produces a small amount of time it's rolling, produces a small potential energy, produces a small acceleration. And something that has a large height is the exact opposite. So it would roll a long distance, would take a long time to roll, would have a lot of potential energy, would have a lot of speed, and then would have a lot of acceleration. So check your numbers to see if that's not being verified. Okay, now we're going to pause the video, and when we come back, I'm going to tell you next how to calculate how long it should have rolled on the ground.